Hello, math teachers, and welcome back to the beginning of a brand new school year. My name is Ryan Timmons. I work with the Dana Center, and I'll be bringing you the solutions to our math fix throughout the year, along with a lot of other initiatives in our communities of practice. You'll be seeing my name along with a lot of posts and discussion starters. You might even, some of you, see me in some of our quarterly trainings. So, without further ado, here is the very first math fix of this school year.
Today's math fix centers around A.CED.2. Create equations in two or more variables to represent relationships between quantities. Graph equations on coordinate axis with labels and scales. This math fix asks students to graph each of the following situations: a bacteria growing that doubles every 5 days and throwing a football to a friend. Then thinking about what things do we need to know in order to make the graphs and what assumptions will we need to make for them to look like. Are there any qualities of the graphs that are similar or different? And then finally, an extension is if the bacteria begin to die after 100 days, how does that change the look of the graph? Well, let's think about that first piece, the assumptions. We might need to assume that there's a certain number of bacteria, so we need some starting values for that. We might also need some starting values for how tall or how we throw in the football. But in general, we don't need to have those exact values. We can start with some general assumptions. What might the graph look like for the bacteria? Well, that's an exponential, and we see that graph on the left here. And then, of course, footballs, depending on how we throw it, whether we throw it up really high and it comes down really close to us, or whether we throw it really long, will be some kind of parabolic arc here. So some of the similarities are they're curved if they're looking at a general sense. We might also talk about them having an increasing slope or a changing slope, whereas the bacteria has an increasing slope, and the football has a decreasing slope up until it gets to the highest point, and then it has an increasing slope. And of course, we've got an open curve versus a fairly closed curve on the football as well. So we've got some similarities and differences here. Then what happens when the bacteria start to die? Well, if they die in an exponential form, we're going to see a peak like this. It's kind of a trick question. Students might think that the graph would look more like the football, but if we want to think about an exponential where they start to have every single time, then we're going to start to have a significant decline and probably have an exponential fall in our values for our bacteria population.
Well, teachers, that's our math fix for the beginning of the year. You'll be seeing me again in a month, so looking forward to hearing how you're implementing these tasks, and welcome back to a brand new school year.